Hello. So in this video we have three separate data tables and we are going to bring them in and learn how to join them and combine them. So let's look at one of them. Let's look at them first. Let's double click. So members table has some columns: member ID, name of the member, Luffy, Zoro, Nami, etc., crew ID, role, age. And this is very common if we bring our data from a database, for example, SQL or something. So let's see at the crew ID. So then let's look at the crew table. So then we have the crew ID, Straw Hats, Buggy Pirates, Arlong, and the members table also links the bounties by the member ID. So in the bounties table is linked to the members table with the member ID. So let's get started. Let me close this, and bring in import pandas as PD, then members is equal to PD dot read CSV, video 10 slash members dot CSV. Then let me copy paste this a couple of times, then crews, bounties, Let's just run this. No errors. Members. So here's our members table. 15 rows. Each one has a member ID, which is their unique identifier. And Pandas also brings this index, right? But our important one is this member ID. So the crew ID column stands out. So these members of this table, which not all of them are pirates, some of them are Marines, right? So crew ID stands out. So now let's look at the crews table. So for example, Luffy, crew ID 101, he's on the Straw Hat Pirates, on the Going Merry. And then let's look at bounties. So here's our bounties table, and just by looking at it, we see that it's linked to the members by the member ID. So we only know one. We only know by looking here who is number one. Well, Luffy. So this is where we need the joining and merging things. So let's do an example. Which ship does each member sail on? Let's say we need this answered. So let's start. So let's analyze this. Which ship does each member? So the ship name is on the cruise table, and the member has a link to the crew. So we need to join these two tables together, right? Joining where this crew ID is equal to this crew ID to add a column of the ship name where this is equal to this, right? Or something like that. So let's see how we can do this. So let me see. Members with crews. This is just a random name of a table I'm about to create with merging the members table with the crews table on what? On crew ID. How left? I will explain this. Let me just members with crews. Let me just run this first. And here we go. It merged two tables, members and crews. On crew ID means where the crew ID was the same, it added the columns on the crew table. And the how left, because there's a how right and other hows, but the left means the first table we mentioned, the one on the left, keeps everyone and attach whatever matches on the right side. So we keep the left table and attach columns on the right where they match the crew ID. Does that make any sense? I don't know. I guess so. And then some jargon. This is called a one-to-many relationship because one same crew, like the Straw Hats, this one crew is on many members. So the same Straw Hat was repeated on Luffy, Zoro, Nami, Usopp, etc. So one to many. There are one to one and many to many. So then, to answer our question properly, we display our member with crews, but just some columns we like we pass in a list of just the name column, the crew name column, and the ship name, for example. And this displays, well, which ship does each members sail on. So we have properly answered, well, just like this, right? So here's the member and the ship he sails on, right? Right. So now let's answer some other question. What is each member's bounty? And this is a comment. Nothing happens. So let's come back and look at our tables. Each member's bounty. So the bounty has a member ID and the member has a member ID. So we need to join the members and the bounties on the member ID, right? That's right. Members with bounties is equal to pd.merge members bounties on what? On member ID, right? Member ID. How? Well, how merge how on label any array like left on? I don't know. I don't understand all this jargon. But we know there's left, inner, and right. Or I think. And let's see it. Members with bounties. Let's first see the whole joined table. And here we go. Kept our members intact. Yes, members table ends on age. And then it will add the columns corresponding to the bounties where this is the same. So this is also 1, 2. Here we don't have many. It's like a 1-to-1, I guess. Anyways, it will keep the left and add the columns to the with the bounties table. So let's look at it. Age, and then this added these 3 columns. And notice the interesting part where on the left side we have a member that is not on the bounties. It kept the row because we said leave the left intact and just add on the right where these are the same. So if there is nothing for this ID, it fills it in with none. So this is where this little how comes into play. The left keeps everything on the left, and whether it has or not, it fills it in with an none if there is nothing on the second table, right? But if we fill it, if we say how, let's do inner. Let's see what happens. So now the table it throws back at us, it's just where there is one on both sides. So everyone without a poster disappeared. And so the rule of thumb here is like this. We just use inner when we care about rows that exist on both tables. And we use left when we want to keep our main table and complete the right side. Now, there is something that sometimes it's difficult to notice, like this little trick. Member ID 16 and 17. So they do not exist on our members. So it did not show with the left or the inner. So then how are we gonna, how can we figure out about these things? So that's why there's another how. Let me see if this works. Yeah, so right side, now it kept the right, kept everything on the right, and displayed none if we do not have a member. But then there is another one. There's an outer, and the outer one keeps all of them of both of them. So the members that do not have a bounty, fill them in with an N on the bounty side. And the bounties that have no members, fill them in with an N on the left side. So this is like a complete join, everything of both of them, and fills an N where on either side we had no info. So there you go. We saw left, right, inner, outer. So to properly answer what is each member's bounty, well, we could either display left and put a 0 where no bounty, or the inner. So that's up to you. Okay. Next question. Can we build one master table with name, crew, ship, and bounty all together? And the answer is yes. We just change the merges of one after another. So let's do this. Full is equal to pd dot merge. What are we merging? Members, crews, on, crew ID, how, left. So this is members and crews left. So members, full members. And then after this is done, then we reassign the full again. Merge. And then what are we merging? Well, this full. And with the third one. Does this make sense? If you were the Pandas main engineer, would you have done it like this? So it's a little bit like cheating, no? We create one table with 2, and then we use that one and add another, and now that has the 3. Full. Pool. Whoops. had an error. Race key error. Can we PD on this line? Our error shows on this line I have a key error. Members ID is member ID. And there we go. We started with the member ID left, so we have every member. And then we added things to the right. So we lose a little information, right? Because we now don't have, for example, all the bounties. Because we have bounties for a couple of guys, these guys, 16 and 17. We don't know who they are, right? And I don't know if we have also, I think we have all of these. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. No, we are also missing the 106. Alvida. We have no one from the Alvida Pirates. So there, if we start from this left and build to the right, we are missing a couple of rows where we have no member, right? So this full, well, it's full if we start on the members. So keep that in mind. Now we have two rows where we have bounties and no crew and no member and no crew name, and we have crew name with no member and no bounty. So if we do outer, we have all the three tables combined. One mega table. Okay. So what if, next question, want to look at two crews side by side. So for this, we do not need a merge. Now that we have the members with crews, we can do something like this. So the straw hats are the member with crews, and and from there we want to apply a filter. Member with crews, where the column crew name is equal to crew name. Straw Hat Pirates, just so I do not spell this wrong. So let's look at this. Straw Hats. So now we have a data frame with only the straw hats. All right. All right, though. Now let's have a R-long. Is their name the column name is still crew name. So let's look at our R-long data frame. Here we go. Now we have data frame with the same structure as the straw hats, but now with the only with the R-long members. So now let's concatenate them. Rivals is equal to pd concat. What are we concatenating? Well, we are concatenating we pass in a list with two data frames, straw hats, comma, R-long. Let's pass in another argument. Well, let's just do it like this. So concatenate, just add rows with the same structure to one table. So it pasted them the rows on the bottom. So this side by side is actually wrong. If we want to look at the crews on one table, maybe, I don't know. Well, anyways, concatenate puts another table. We have two tables, right? Straw hats and R-long with the same structure, and kept the indexes. So this is why it skips from 4 to 8. So this is why if we pass another argument with ignore index equals true, now our rivals table will have a complete new reset index because it ignored the index number from the original table. So this concat stacks the data frames. The word I was looking for is stacks them, one on top of the other. So let's add a third one. Let me do it over here. I just paste it so I can then say Marines, and then from the members with crews crew name, and then we are going to bring in these three guys. Marines. Here we are. So now let's three-way pd.concat, and then the same thing we already did. We did over here concat. What are we concatenating now? So we pass in a list. We could concat the R-long straw hats, or we could let's concat rivals and then the Marines. Three-way. Here we go. Again with the index. So let's ignore index equal true. So here we go. Now we have stacked together straw hats, Arlong, and Marines. Here I did the same trick as with the joining. First I joined two and then named that rivals and then use the rivals to stack Marines on the bottom of that. I could have done straw hats and Arlong here. Straw hats Arlong. And it's the same table. Straw hats, Arlong, and Marines. So let me scroll all the way to the top, do a little summary of what we did. We brought in 3 tables, and then we started by doing this in ask questions first to look at how merge works. And then we saw how merge left, inner, outer, inner, left, right, inner, outer. And we saw how those work. I did a couple of examples of that. And then we did 2 examples of concatenating, which means stacking one table on top of another that have the same structure. So that will be it for this video. Thanks a lot for watching. See you on the next one. Bye bye.